So we have discussed that the y will be equal to sum of n random variables, that is x1 plus x2 plus x3 so on xn. Then probability density function of sum of n random variables will be equal to convolution of the probability density function of individual random variables. Okay. So the density function of sum of n statistically independent random variables is equal to convolution of their individual density functions. Okay. So the central limit theorem says that if this n value approaches infinity, that is we have sum of infinite number of random variables. In that case, the probability density function of sum of infinite number of random variables will be approaching Gaussian density function. This is called central limit theorem. Okay. So the central limit theorem states that the probability density function of sum of n independent random variables approaching Gaussian density function as n tends to infinity. Okay. And this central limit theorem can be applied for statistically dependent random variables as well as statistically independent random variables. We can apply this central limit theorem for statistically dependent as well as statistically independent random variables. Okay. And we also discussed that the central limit theorem says that for large n, the distribution of sum of n random variables, that is y is equal to x1 plus x2 plus so on xn, is approximately normal. So what is the distribution of sum of n random variables? Will be approximately normal regardless of form of distribution function of individual random variables. Okay. So individual random variable can have any form, but the sum of n random variables, if n is large, will be having normal distribution. Okay. And we also discussed that whenever we are observing a random variable, say that random variable is sum of large number of random variables. Okay. So at the receiver, for example, you are observing what is the signal we are receiving. Okay. So the received signal will be sum of information and noise signals. The noise signals, we will be having different noise signals from the different sources. Okay. In that case, according to central limit theorem, what is that? The sum gives us the Gaussian distributed random variables. Okay. So what is the received signal? The received signal will have Gaussian distribution. Okay. And here we have two cases. The first case is unequal distributions. Okay. So here what is that we are doing? We are taking n random variables. Xn is equal to 1, n is equal to 1 to so on capital N, have arbitrary probability densities. Okay. What is the mean of this? Is xn bar, x1, xn bar, and the variance is sigma xn square is the variance. Okay. And the central limit theorem states that, say the random variable y will be equal to what? X1 plus x2 plus x3 so on xn. So this is the random variable y. X1 plus x2 plus x3 plus so on xn. It is sum of n random variables. Okay. Then the mean value xn bar. What is mean value of the sum of n random variables? Is xn bar is equal to what? X1. It is sum of the mean of individual random variables, that is x1 bar plus x2 bar plus x3 bar so on xn bar. Okay. And the variance, what is the variance of y here? The variance of y is given as sigma y square. Sigma y square will be sigma x1 square plus sigma x2 square plus so on sigma xn square. This is the variance of the sum of n random variables, that is the sum of variance of individual random variable. Okay. So this variance will have the probability distribution function that will be approaching Gaussian distribution function when n value tends to infinity. Okay, that's what central limit theorem says. Okay, if n value approaches infinity, what is the probability distribution function of sum of infinite number of random variables? It will be approaching Gaussian distribution function. Okay. And what is the necessary condition? Sufficient condition here is the variance of individual random variable should be positive, and also the expected value of mod xn minus xn bar cube, okay, should also be positive. So b1 b2 should be positive. This is the sufficient condition for getting the sum of the distribution function of sum of n random variables as a Gaussian distribution function. Okay, so if these two conditions should be satisfied, what is that? The variance should be positive and expected value of mod xn minus xn bars whole cube should also be positive. Okay, this is the case for unequal distributions. Now we'll discuss the case for equal distributions. Okay. In the case of equal distributions, each random variable have same distribution. All the random variables. Here, how many random variables we are considering? We have considered n random variables. All these random variables will have equal same distribution and density functions. Okay. That is why what is this called? Equal distribution. Okay. Then what is y here? Y will be sum of n random variables. Y is equal to x1 plus x2 plus so on xn. Okay, y is sum of n random variables. Okay. Now we are defining w. What is w? W will be defined as normalized random variable. How do you define normalized random variable? The normalized random variable will be given by this equation. So w is equal to y minus y bar by sigma x, that is called normalized random variable. Okay, now each random variable is having same distribution and density function. Okay, no, now how do you write y? Y can be written as summation n is equal to 1 to n xn. Okay. What is y? x1 plus x2 plus so on xn. No? So that we are writing in the equation form. That is summation n is equal to 1 to n xn. Now what is y bar? Y bar will be summation n is equal to 1 to n xn bar. Okay. And what is sigma y? Sigma y will be what? It is sum of variance of individual random variables. It is summation n is equal to 1 to n sigma xn square. Yes or no? Now we substitute the same thing here. So w will be equal to what? W is y minus y bar by sigma y. Y we have discussed. It is summation n is equal to 1 to n xn. Okay. Y bar is summation n is equal to 1 to n xn bar, and what is sigma y? Sigma y is square root of summation n is equal to 1 to n sigma xn square. Okay, so the same thing we have substituted here. Since all the random variables have the same distribution, what is that here? All the random variables have same distribution. So what is sigma xn square? Will be sigma x square only, because all the random variables have same distribution. That is why sigma x1 square will be equal to sigma x2 square, that is equal to sigma x3 square, that is equal to sigma x square. Okay, all the random variables have the same distribution. Okay, so it can be written as summation n is equal to 1 to n square root of sigma xn square whole power 1 by 2. Okay, since all the random variables are having same distribution, we are adding all them. Okay, instead of taking separate terms, we are taking only one term. Okay, so that is equal to square root of n sigma x square, because we are adding this n times, no? So it is square root of n sigma x square. So it is equal to square root of sigma x. Okay. Then we also discussed that xn bar is equal to x bar, because each random variable is having the same mean value. So that is why this can be written as summation n is equal to 1 to n xn minus x bar by square root of n sigma x. Okay. Where this w, this is the normalized random variable. No? This w will be having is a Gaussian random variable. This w is having the form of Gaussian random variable. That is why this w is called Gaussian random variable.